Okay, I hope you enjoy your lunch. Oh man, it's too light, too much light. So we have one and a half hours now for the first discussion. My name is Dimitrios Arouchas. Maybe you know me, maybe you don't. I'm a colleague of Bruno Santos, the coordinator. He's the boss, I'm the monkey here, that's why I have my banana to start. But please, because it's going to be 2 hours, I guess everyone needs some vitamins, so I got something to eat. So we are going to discuss the first 1.5 hours, the technology around ReMAP, and some of the results that we have seen today. So we have a very nice panel that I would like to introduce, starting with Marcel Bosch from NLR. Hello, Marcel, and welcome. Please take a chair, sit here. Yes? Yeah, the green one, yeah, that doesn't matter. Then, of course, then coming from all the way from Brazil, right? Paulo Anchieta from Embraer. So thank you, Paulo. Last but not least, Anthony Stillow from American Airlines. So I would like to give you the opportunity. Of course, I will take also a chair myself to sit. We are not going to play music chairs here, so I will sit myself. First of all, I would like to ask you to introduce yourself to the audience, say a few words of what you are doing from all of you, and then we will start with some points that sure. I have made.
Am I on? I think.
Yeah.
Yeah. Oh, okay. My name is Marcel Bos. I work with the Netherlands Aerospace Center. It used to be called Netherlands Aerospace Laboratory, but we figured that laboratory was old-fashioned, so we're a center now. But nothing has changed. I've been with NLR for 22 years now, and since 2 years I'm the head of the Aerospace Vehicles Integrity and Lifecycle Support Department. My main customer is our defense, and mainly the Netherlands Air Force, though we have other customers as well. And what we do is we keep track of the fleets, the usage of the fleet. We do loads and usage monitoring. We develop degradation models for the fleet. We do structural testing, and more we're moving to other systems as well. So not only structure, but also systems, aircraft systems. And all the buzzwords that are around, we are interested in the digital twinning, predictive maintenance, condition-based maintenance, etc. Structural health monitoring, we are mainly focused on fiber optic-based structural health monitoring, though we're interested, of course, also in acoustic emission, piezo-based stuff. But fiber optics is our main core, if you like, when we talk about structural health monitoring. But our fleets are really still instrumented with very conventional strain gauges, and we read out all the digital data buses. Modern fleets nowadays, also from the Air Force, they all have a digital cockpit, so all the data is available, and we do that on a routine basis, which gives us a unique position that we have huge data sets of data, and we're only scratching the surface, if you like. So there's a lot of work still to be done. Yeah.
Amazing.
So, yeah.
Amazing. So we have ReMAP within one person.
Yes.
This what I could say from what Marcel. Great. Paulo, a few words for yourself.
Yes. Wow.
It's loud, right?
Good afternoon, people. I work in Embraer 36 years, and stress analysis and for development this fatigue monitoring in defense aircrafts. 36 years development these systems for indirect SATM monitoring. 15 years ago, work in this prepare for commercial aircraft in SATM, and then in development area, in technology and development area. We work to many methods in the SATM for acoustic emission, fiber back gratings, lamp waves, CBM, impedance, others technologies and process, and the discussions about these qualification processes and the idea for qualification process together, regulators, and participated in the influence in ACA committees. My experience about this development of these systems, together my team is prepare for semi-applications, proof of concept about this. And 5 years ago, 4 years ago, participate together, Dimitrios and the team for the ReMAP. For us, it's very interesting, this participate. For me, it's more one experience of that collaboration for many guys, special guys and the specialists guys, for this challenging to use the SATM and PHM when the vision for CBM is. Thank you, you guys. Thank you. It's for Embraer. It's very important, including these systems, because we know this have one value in the credits and benefit, the maintenance about this. Okay? Thank you.
Thank you, Ansieta. One thing that is extremely important, as Ansieta said, he works for 36 years in Embraer, so imagine the experience that he brings to us and the discussions that we had when we decided to build the ReMAP project. So on behalf of everyone, I would like also to thank you for your contribution. Anthony, a few words for yourself.
Sure. My name is Anthony Stillow, predictive maintenance engineer for American Airlines. So we had some great presentations this morning. Our team is a team of several engineers that basically team with our subject matter expert engineers at American Airlines, and we basically partner with them to harness the power of the sensor data that we have on our aircraft to improve aircraft operations. I'll say my experience and perspective is probably a contrast to the other two gentlemen here, but I'm happy to be here and happy to engage in this. There's certainly a lot of value for airlines as well as all of the stakeholders in condition-based maintenance. So.
Great, thanks. As our coordinator said this morning, this would be, we'd like to have a discussion with everyone, so please, anytime, if you have something to add or something to ask, feel free. We have the magic box there, so I would like to have an interactive discussion. Hopefully, this will be via our panelists. One thing that I would like to challenge you, starting with maybe with Marcel, with you, we discussed also during the lunch. Of course, we didn't do everything perfect in ReMAP, which makes sense. Can you pinpoint few things that you believe that was not the case, or with your experience, you would do it a bit differently?
There's one thing that struck me that you did quite right. I wrote a paper a few years ago about SHM and the reasons why SHM doesn't take off yet as much as it should. And there are two main problems there. One is certification, which is still an issue, and the other one is developing a good business case and going to the paradigm shift of to condition-based maintenance. And apparently you have resolved the latter aspect because you've shown that it's perfectly it's there. The technology is there and can be aligned with maintenance practices. So that's well done. And I think I can't really say that you've done anything wrong because PHM, SHM, it's a huge monster. And you cannot expect that in a single program that you will resolve all aspects. It's very good kickoff for more work. So I think you did great.
Thanks. During the presentation of Theo, we've seen these testing coupons that we have here, and then the bigger one. So we introduced the hierarchical testing.
Yes.
How do you see that? And for us, it was actually a very, a very thoughtful way of going there. We had a lot of discussions of maybe hierarchical testing following the building block approach that Aerospace uses. We have to combine it with SHM in order to prove all the levels of structural health monitoring. We found many difficulties during the process with the testing. You know, we are doing a lot of experiments, and that brings a lot of problems. But do you see that the hierarchical testing helps the SHM integration?
I must admit, when you sent me the questions, or sort of the philosophy of questioning last week, and you mentioned hierarchical testing, and I initially thought, okay, that's indeed the testing pyramid. But then I did some research on the internet, and hierarchical testing, as it turns out, it's a statistical technique as well to separate if you have a multivariate data set and you want to pinpoint the most important predictive variables that really determine the response. It's a very specific technology in statistics as well. So I really was put on the wrong track there. But my first interpretation of hierarchical testing, I believe that's the way to go forward. I mean, it's nothing different from what we do in structures testing, having test pyramid. Though what you see there is that the test pyramid used to be like a real pyramid, but now that virtual testing, and that applies to SHM, of course, as well, the pyramid becomes less a pyramid, but more a pagoda, or how you call it. So I believe that model-based engineering, model-assisted certification is really the way forward. Okay. Yeah. It's inevitable because there's so many variables that you cannot cover in a rational way by only testing, that you have to go to a model-based approach as well.
Ansieta, what's your opinion on the hierarchical testing, and how do you do it in Embraer?
Yeah, this is very important because the block by block, yeah, is the firstly is the understand the phenomenon. SATM, for example, you need for the coupons for understand in the conditions in the environments, the conditions for other situations about the construction algorithms and the filters about this. This is very important. If it is based the technologies. We talk about the repairs. I thought this is very important to understand. Very important. Construction. This is very. If you don't have this many domain about this is not possible. Change this for application one nested one subcomponent. It's either not one component, but on level 2, for example. Yeah? Because you have more understand, but one more structure. And after this is application on the large aircraft, a larger component in aircraft for this is block by block in the hierarchical tests. We need this. If you direct it to when I need to the SATM, Fernando Dotto participated here. One of my guys, Embraer guys, is participating in web. Remember, this firstly is just installing in full scale fatigue test, okay, on the E-jets, and verify. Okay, is this initial? Is it done or no? Is good or not good? But when what is good, but we need to understand better for situation, for the technologies, for the process. We have to come back to block by block. The team for many coupons, for many tests together. These technology institutes, yes, and this is very important. It's not only the STM, PHM2. You need to understand. You need for firstly better minus variables, one simulation about this for constructing this. This is very important. Okay. Sorry, it's possible. About the integration, let's talk about integrations.
Yeah, that is the thing that I would like now to introduce. And
that's okay.
Anthony, about via the hierarchical testing that we can do, and we have the several techniques there. We need somehow to come with an integration.
Yeah.
And the integration is not easy to put it like that. So when it comes to the operation, and you get an aircraft that has been manufactured, and there are so many sensors on board that they do different things. How you as an operator see the integration?
So I think there's a couple of main points about integration. So first, having a sensor available, sensorizing the system, sensorizing the structure is foundational. The second kind of dependency upon sensorization would be having an efficient, robust way to determine which sensor is a true indicator of condition. And if it's an indicator of condition, is it a leading indicator? Does it give you any sort of prediction or lead time to allow you to predict a failure? And those things are all interdependent and foundational, I think. And I think when a system is in design and certification, those must be kept in mind to enable condition-based maintenance.
Okay. Yeah, sorry. This is a very important discussion for us. Because the best strategy would be to be able to use the sensors and the data that already exists in the aircraft. This is very good. But to perform to a PHM, for example, but this is you perform to indirect SATM for operational load monitoring in aircraft, you need variable for read, it's the same. Perform system prediction, but we know that this is not at all possible. No, sometimes don't have the variable, don't have the data acquisition our need. Yes, new sensors and new parameters must be added for you have this. For example, SATM. You need for us. The existence of the parameters at adequate the acquisition rates will improve the reliability of the algorithms. Reliability is very important. This is key. Key is reliability of the systems. This is very, very important. It is no use thinking about it performance CBM without reliability until an adequate level. If it's possible, there may be cases where some components is replaced much sooner than it should. Or, in other hand, it could increase the probability of an unscheduled event. This case for us, is customers and the operators, it's possible to lose for confidence in the prediction algorithms. This is not good. We want this and not good results, okay? For us, this integration is very important. This is practical, it's possible, but don't forget, when you need, for example, CTM, you have one good system, acoustic emission, but another other system together I have the localization, good quantification. But when I include in this, it's possible, it's very onerous, very expensive, and very complexity for validation and qualification the system in the regulators. This is one challenge about CBM. We need this about the analyze prognosis when they included digital twin. This is for me is only way about CBM and SATM, for example. But in structural, for example. But we need for understand better this. You use, for example, machine learning or artificial intelligence. Good. This promises this. But because SATM and PTM, when I talk about the regulators, is we need use the regulators, the conditions in the conditions for defining the regulators about the NDT systems, for example. Is machine learning and artificial intelligence is the same. About this EASA, when one new guide about this, we need for understand, study, talk about GULERM in EASA, but we construction this in CBM, in using the machine learning. Is possible your opinion about this, because need construct it together if you want credits in the future in operators. Good.
Bruno, there are, because also our online partners. Okay.
Two questions online. So first is if the aerospace industry is bringing any standards for PHM or SHM for aircraft that have that capabilities. That's the first question. So standards being provided, and the second one is for legacy systems with no sensors. How can PHM be implemented, or time to replace can be found on those systems?
David.
So two questions. There's also there.
Also, David,
Yeah.
maybe would like to address that. Yeah.
I'll take the first one at least. So I'm chairman of the Aerospace Industry Steering Committee on Structural Health Monitoring. So yes, there is a standards mechanism for that. And there's a couple of documents. We actually have a document on guidelines for implementing structural health monitoring on fixed wing civil aircraft. The Health Management 1 committee under SAE has several more documents on creating the entire hierarchy, if you will. So the requirements document, the architecture of your system, how to do validation and verification, and all the way to a cost analysis for all that. So yes, standards do exist, and there's many more that are in work, including on artificial intelligence, how to certify artificial intelligence kind of applications.
Can I add to that, David?
Yes.
EASA last week issued a new notice of proposed amendment of one of the CS29 articles. It's for large rotorcrafts on vibration-based health monitoring of rotorcraft. And it provides acceptable means of compliance and guidance materials. And it's only out there for a week or so, but it could be interesting to have a look at that.
Yeah.
So.
The second question, I don't remember, no.
For legacy systems with no sensors, how can PHM be implemented or time to replace be found? That's the question. Legacy systems.
I guess I'll get started with that one. I think one of the struggles is lack of sensor data. And one of the ways to address that is, particularly for the PHM side, systems maintenance, is analyzing the system to see where a sensor might be valuable. Often systems on aircraft have control sensors installed. Whether or not those are available to be recorded as the delivered configuration of the aircraft are two separate conditions. What is available, and it is something that has been pursued by airlines before, and OEMs, is a modification to the aircraft that allows you to capture that data. Obviously, there's a cost associated with that modification, and so that would be applicable mostly to systems where there is significant impact to the operation and room for improvement and cost avoidance due to avoided cancellations or delays. So.
Another question.
Oh, sorry. I can add to that from a defense perspective that, well, at least Netherlands Air Force, but also other air forces are quite keen or can be keen on instrumenting the aircraft because the usage variations in military aircraft can be quite significant. And especially, well, for instance, C-130, Hercules transport aircraft, we have a fairly simple loads and usage monitoring program in place there. It's only monitoring a handful of parameters and NZ exceedances and stuff like that. But interestingly is that the structural maintenance plan is based on equivalent flight hours rather than flight hours. An equivalent flight hour is simply, well, if you fly very severely, whatever that may be, your equivalent flight hours become more than your actual flight hours, and you have to do your maintenance inspections, your structural integrity-based maintenance inspections more often. And because that manual is based on equivalent flight hours, there's a real impetus for the operator to try and determine the equivalent flight hours as accurate as possible. And you have to instrument your aircraft then.
Marcel, nowadays, how do we measure the in-flight severity? How do we do that? Is it due to the pilot or?
No, it's a relatively simple approach. It's based on what we call data block method. It's based on a database that Lockheed Martin has provided to us. And we're keeping track of points in the sky, and each point in the sky, so a combination of altitude, velocity, all up weight, well, a few more parameters. Each point in the sky has a specific damage rate associated with it, and simply bookkeeping of your points in the sky and then adding the numbers, and in the end you know your severity of the flight. It's relatively simple, but it's very effective.
Yes,
yeah.
I was not aware of that. Yeah. There was a comment or question from this side. No? Okay, then maybe I didn't see well. I would like to stick a bit more on the reliability and efficiency of the sensors, and I want to be a bit provocative here because what we have seen, at least what I have personally seen, because I like to play with the machine learning algorithms, is that it can give us reliability to a level that we don't understand, and although we see in the lab that some sensors fail actually. So how can we be as engineers and, because we want to avoid that, how can we ensure that when AI will come to the game, and it's coming, this is something that we are not going to avoid, that the reliability will remain in a level that we as human beings, we understand. So what is your opinion on that?
Yeah, that's a challenge. No, I guess, well, maybe, but I'm just thinking aloud here. Maybe one way of approaching that would be to add a virtual sensor. So model your real sensor, have a virtual sensor which takes the signals from the digital data buses or whatever, and have it run in parallel. And if it starts to deviate, you may, that may be an indication of your failing sensor.
So the concept of digital twin, we transfer it also to the sensors.
In fact,
okay.
Yeah.
Okay, so we don't model the structure, but also with the sensors embedded.
I guess that could be an approach, but again, I'm thinking aloud here.
That's why we are here, right?
Yes, of course.
Perfect.
But of course, for like strain gauges, there are other ways of doing it. You can check your zero settings, and if they start drifting, then you know that something is wrong. But that's for strain gauges, but there are more complicated sensors there. But it's a very important topic, because if you can't trust your sensors, you're lost, obviously.
Okay. And what about the feasibility of the efficiency of sensorizing either a structure or aircraft system in terms of how many sensors we need, how we are going to wire them, what is the all the implications that they are coming when we decide to put a sensor on that. How can we overcome? Because that was out of the part of ReMAP, so we didn't touch upon that, and we did it there with a decision making together with Theo when we were writing the part of SHM. We decided not to touch that. But we've seen it that is extremely, extremely important to talk about the effectiveness, efficiency of the sensors themselves. So, what is your opinion on that? Yeah, Anthony.
Yeah.
I think reliability of the sensor is core. From practical experience, the way that a sensor fails is often different from the way that a system fails. That in experience is something that can be addressed. Other than that, I think that the feasibility of sensorization is something that is a concern for CBM due to the complexity of the aircraft system as a whole. There are hundreds of aircraft systems that are operating, and for each of those systems, often hundreds of sensors would really be necessary to monitor for every failure mode. So I think feasibility is something that should be kept in mind, and potentially maybe there should be some sort of prioritization that during the design of an aircraft, certain systems are known probably to be more complex and more problematic in operations. Those are the ones I think that should first be addressed for sensorization. And feasibility downstream from the sensor is something else that would need to also be addressed, which is something that was touched on earlier in several presentations, is just the vast amounts of data. So as you add more sensors, the size of the data will only obviously increase from there. So.
Did you sorry.
No, it's okay.
No, it's just a question. Did you actually sensorize equipment in your fleet as an operator?
We've, I'll say, as far as a hardware modification, we haven't yet, but we certainly have increased and expanded the sensors that are being recorded on the aircraft and then being decoded offline. So certainly that's kind of the phase that we're in now, is expanding and optimizing what we're currently recording. There are certain fleets, obviously, that provide more sensor data as delivered than others. So certainly certain fleets that are not sensorized, those would be the ones that we would target for modification to install sensors or to record existing sensors.
This is a very, very complex. For example, it's one focus about the systems, SATM system or PHM systems, is good algorithms, is robust algorithms, okay. But it's using the application for credits in maintenance, for example, we need for the data, for read this data, this aircraft is very robust. This is not easy because flight by flight, this is okay. One flight is internet, I downloaded this. But when design this aircraft, when I design this aircraft, did not define this information, these sensors, we need level qualification software for read this, for don't have one good information about this. I lost information, not good information about this transmission, this information. Data acquisitions, this is the ecosystems for the SATM or PHM system. You need for read this outside aircraft. Not good. This don't have credits about this. It's not cheap, because the FAA says, okay, so you want this flap or system, you want this to read this you want the credits for maintenance about this? Okay, the software read this is level C, level B, level A? No, sorry. It's not possible. You have the good, robust system, PHM, but not possible credits about the maintenance, because we need to change the system about this. This is one problem when I wanted to use the system in integration. Or more times we need to include other systems, integrated systems, more complex about this. Okay, it's not easy. Okay? But this is possible. I talk about Bruno talk about this. We need to try design the new aircraft and prepare this for maintainability aircraft. For I have the credits about this. It's very important.
But as Bruno said I think it was in the introduction or during the QA session, if we do that, then we are heading to 2050 when the new aircrafts will come into service, and then CBM may become to 2060, and most likely, we'll be in a Greek island drinking, no, maybe not,
no,
I will be dead, but anyhow, 2060. So we need it to happen sooner, right?
Mm-hmm.
You better start drinking now.
Yeah. No, you need this,
tonight.
You are correct. Yes.
You really need to approach it on a system level, because if you're going to trust an SHM system or PHM system, then you're redistributing your risk. You're introducing a new risk. So it really has to be balanced. So if you have your risk of 1 times 10 to the minus 7 per flight hour, whatever it is, you distribute it over the systems, then that's the way to go about. It can only be done in a system level.
This is because this application, why not application, the PHM, SHM, is aircraft? It's not easy to define one good application for have the credits for the various credits, because you need to include the sensors, you need to include the cables, you need to include the one data acquisition headquarters, you need it for this, you need this for communication for the system for aircraft for this information. I need the information, the one equipment. This equipment don't have the rate, simple rate. 50 weight is not good. No, sorry. I need this 128 rate this information, because it's very important about this reliability. Okay, it's possible to change. No, because this equipment don't have this information. Why? Sorry. Because when you go to this more discussion, when need more weight. Wait. This is SATM, for example. You need the cables. How weight is 30 kilos. 30 kilos? Yes. In the monitoring hotspot, sorry, in the maintenance task, don't have. I need one large area. I need a large area. Yes, only this center fuselage. Oh yes, only the center fuselage is. I need to. The task is get out this. This seat, this internal for verify this. Okay, so if you want put it, SHM, only this system. Wow, it's not today. It's impossible. It's good. Always sensors. Yes, we need for discussion about the application. It is for SHM. For us today is need more discussion about the large areas for but robust, not onerous, not expensive. It's in the needed for comparison for or the task today is visual task. Oh, you need to tell. It's more important because I change the visual task, visual inspection. Sorry. In the SATM, yes, you don't need more disassembly about the system. Disassembly about the internal aircraft. This is amazing, but it only costed us. Yeah, it's very interesting.
David, you still have the magic box, right? Yeah.
Yes, I do. So Paulo makes a very good point, and basically, bottom line, it comes down to money. It comes down to money, the cost of putting a system on, but also, if you're talking weight of the system, fuel efficiency. Fuel is a huge cost. type of thing. So one of the things I want to ask the committee, ask the panelists kind of thing, what's the possibility of wireless sensors on board? And basically, right now, today, I have a need to monitor some cracking that's going on my wings. I don't want to run cabling the entire wing. It's too heavy. It's too heavy. So I want to put sensors out on the wing for that. And basically, we put winglets on to save money, to save fuel and money. So sustainability and cost. But there's some things that are going on that I need a sensor out there, and I can't do that with current technology. I need a wireless sensor. So what do you guys think of?
Yes.
If we went to wireless, what would be the problems? Or
Yes.
what do you
Sorry.
think?
Possible?
An obvious thing is my customer in defense doesn't want wireless because they don't want Wi-Fi on board because of whatever reason. Well, you can imagine, but
There you go.
but please take over.
That's okay. So, I studied these wireless sensors and including this system in full-scale fatigue test for verify. If you use the application in the SATM for NDT in ground station, ground station for aircraft don't fly, it's change the SATM for NDT task, NDT process, only ground, not fly. I think so. Wi-Fi is one good approach. You need more one RUBY, in my opinion, one RUBY. For sensors that link the RUBY and the sensor, the information for outside. This is good. But only for me is now is ground. It's in flight, for example. This is different, understand about the physics. Corrosion or crack don't happen. Different for systems. Yes, one light is on off, but in a CTM, maybe the event for corrosion, event for delamination, event for crack fatigue is very different for cycles. It's possible verify when aircraft on ground in taxi, the gate, and the Wi-Fi information. As this idea. It's possible to work this in CBM STM. But in this case, for PHM, I think so is very studied about this, using the Wi-Fi, because it's not easy or not the regulations for analyze about this, because the information, traffic is in the information discussions about in flight. It's David, it's possible. We are studying about this. Study in testing the full-scale fatigue test. We have the control room, yes, and it verify this communication, and it's possible in the future. But in flight, my opinion is thinking CBM, because online is a matter. Is maybe the future. Now, my opinion, we use the cable for guarantee this reliability about this, okay?
I guess for ad hoc measurements, it's quite okay, but for routine loads and usage monitoring, you always have the power issue, and you don't want to have to re-battery your sensors. And Wi-Fi, of course, also when it's internal in the structure, well, you got all these problems with transmission.
Yeah.
That's the other aspect, is providing power to your system. And so those are wires, and those are batteries, and those are not pleasant in an operational environment. Two other things that can go wrong that we have to account for and have risk mitigation for that. So,
good.
There is a question from online.
Get sound here.
Sound to Bruno.
So
Sound to the coordinator. Coordinator asks sound, please. The coordinator,
Sorry,
yes.
the boss. No, boss. Sorry.
I have a question which is related with what we are discussing from the audience online, which is about weight. So what is acceptable in terms of the weight that we can put on the aircraft to have SHM, and what researchers can assume that will be acceptable in terms of weight?
Depending, okay? Depending. When I have one application, this system, for example, SATM, I verify firstly this how cost today for inspection about this. Okay, depending this case, it is necessary, and the weight 5, 7 kilos depends. Okay, but if I need for it's very expensive for inspection task now, because you need disassembly, you need maybe not probably have more weight in this discussion. This is case by case, okay? Yeah. It's case by case. And verify this. For us, we try, Dr. for me remember, it's 3 or 4 kilos for installations in BS in aircraft. Yes, you remember this?
For serviceability, we done with. Are you listening?
No, no. Take the cube. Take the cube.
Coming down.
Okay, now you listen me. For the work we done with Airlines, our serviceabilities are done adding to aircraft like 4 to 5 kilos of material, including our cables, standby connectors, sensors, seal lamps, everything. So it's
three regions of the application.
Well, it's yes, for the 3 serviceabilities we've done, there are 3 regions. 2 regions on the PAX door, on the passenger door, 1 region inside the fuselage close to the wings, and 1 at the back. There's 2 we done for endurance testing this on this project with Azul Airlines.
But Bruno, is this one trade-off about one application? Okay, it's possible to reduce this weight. I think so, because this is used the material and the system, the hardware, in development technologies, in phase of the development.
We get the minimum weight you can get for this application. It's pretty close for the real application. It's a lot of sensor there, because on the back store there is, let me count it, like 15, well, about 25 PZTs and 10 CBM sensors around the door, plus more 10 around the aircraft, 10 to 15 sensors. So it's pretty good, close to real application for airline.
David, in Bookhead in 737, do you know this weight for use? The CVM? CVM application 737, Bookhead.
On the aft pressure bulkhead, it is basically I say a pound or less. So we're talking 2 kilos.
Yeah, it's the same.
I think. Yeah. Now it's basically a Teflon silicon sensor and Teflon air tubing. So it's really, really lightweight. The piezoelectric, just by the nature, has heavier cables.
Good, thank you. Thank you, Dota. Thank you, David, for your opinion.
Theo, first to Mark.
And respect the order.
Yes. Just one comment on...
Thank you.
Please, Dimitrios, this guy.
Just one comment on kind of the weight and what would be acceptable. I think what needs to be kept in mind is the balance, right? You don't want the balance of monitoring and censoring a system to outweigh the potential benefit of monitoring that condition. Yeah. Similar to the balance that was shown for the scheduling model earlier, the same could be true for this question.
Yeah.
Because to go on that weight question, one common argument is to say that we can reduce safety margins when we have a SHM system installed on the structure. So, for example, we can reduce the thickness and thus save some weight on one side and lose some weight because you install cables and sensors. So, some papers, and I think we wrote that in a ReMAP proposal, talk about 5% of weight saving. So do you think it's something that is achievable and that seems reasonable?
I guess you could put the other way around as well. Say in 2050, when all equipment has built-in PHM functionality, you could sort of require the subcontractors, the suppliers to go, okay, this is your weight budget, and please give me your system, including a built-in PHM. And of course, the aircraft would have to have a PHM data bus or something like that. Mm-hmm. You'd have to have good data interface protocols, etc., etc. But you'd sort of get away from the weight issue because it's all designed in, if you like. But okay, that's future.
If I may add to this discussion, it became clear after ReMAP that each sensing technology has different weight penalties. PCTs are clearly, lamp wave interrogation is clearly heavier because it involves a lot of cabling for every PCT sensor. But on the other hand, it gives you very subtle, very precise measurements. Optical fiber sensing is definitely more attractive from that perspective because you can have only one optical fiber with several points sensing. There is no electricity. It's only light traveling through the optical fiber, so there is no spark, danger. But it has different accuracies, if we can say so. It's totally relative. On the other aspect, what Mark just said on the direction of reducing or relaxing the safety factors when one uses SHM, we can definitely say that you can relax the safety factors when you design and obtain linear structures. And what we definitely learned in ReMAP, where we put composite structures under millions of cycles of fatigue, we understood. Probably the guys from Airbus already knew that, but we understood that these structures are remarkably damage tolerant. Remarkably. We struggled to propagate damage. We struggled to propagate damage. Initial impact damage or disbonds. So one has to, it's a very complex, very multi-factor issue, and it all comes down to challenges. If I might see the way forward, and if truly the industry wants to go to this direction, I would say, as with David we discussed a little bit today, let's take small steps forward. Choose, as Delta already had with the CBM sensors targeting specific locations. We should expand these paradigms to probably other areas that are damage prone or hotspots interesting to be monitored. With small steps, but every time with more key players involved, with more data gathered, with more data shared, and I think all these serve this discussion towards future deployment. But it comes at the same time. This discussion very nicely brings up all the issues, challenges, problems that we faced during ReMAP. And one thing, and let me close here, one thing is for sure, that ReMAP opened more questions than it answered. And from that aspect, it's very, you know.
Unfortunately, we don't have anyone from EU now. Maybe they hear us from online. Where are the cameras? We definitely need ReMAP 2 funding. Yes, that's for sure.
2, 3, and 4.
This is a friend. Eh? Friend is good.
Yes.
May I reply to that? I may have a small step for you that could be interesting, and it's a bit military aviation based, but I'm sure that be a civil aviation parallel as well. But in military aviation, there are two ways of reaching damage tolerance: either slow crack growth or fail safety damage tolerance. And if you go for fail safety damage tolerance, and what we see in our F-16 fleet is that it's becoming very popular because the awareness has grown that the detectable crack sizes that were assumed initially in the design were a little optimistic, and the actual crack sizes that you can find are bigger, so your remaining safe interval for inspection is too small. So in many instances, they go to fail safety damage tolerance. And if you go to fail safety damage tolerance, you only have to do preferably a visual inspection of the primary component, knowing that if it fails, you still have the secondary component, and that you're still safe for the flight or a number of flights until repair. If you add an SHM system to such a construct, you still rely on your visual measurements, but hopefully your SHM system will be able to prognose the incipient failure of the primary element before it actually fails, with the advantage that the repair will be much cheaper, because if it completely fails, your repair is much more expensive. So if you can detect it more earlier, then your repair will be easier. And if the SHM system fails to detect it, you're still safe because you still rely on your visual inspections. So that could be a sort of easy, low-hanging fruit type of thing for demonstrating an SHM system in real flight. And that's what we're talking about, because it's nice to do all your laboratory work, but the real problems always arise in operation. And, yeah.
Just a comment for the students that they are writing Veni Vidi proposal CRC. Please take this as an advance and write a nice proposal.
Just a quick comment regarding the safety margins we're talking about to reduce. For those who are not too intimate to aerospace design and everything else, and currently the regulation is of course, all OEMs go a higher safety margins to designs because it's safe, but with SGM allow us to reduce until we can reach the allowables. Allowables is the minimum strength, remaining strength you get for the structures. So we cannot do below that. Also, we need to consider two types of structures. Let's roughly describe it on the aircraft. We are, let's call regular ones for your better understanding, and airworthiness limitation inspection. That's a principal structure, very critical structure. So we cannot go under inspection that on that structure is limited for the structure designs. So that's currently regulations we have with the certification authorities for everyone basically everyone around the world.
Bruno had a question.
You can give it to me so that I don't have to change it. Micros. Yes. So it's okay. Okay. I have a question now, so, and I'll try to also change a little bit to PHM. So we talk about data-driven models.
Data-driven.
What we do when a new aircraft gets into operations, there is no data. So how can we rely on PHM? Or in a similar way, as it happened with us within ReMAP, we identify a system that had frequent failures or frequent reparations needed. There was data. For other reasons, was also a suitable system for PHM. We developed the model, but at the same time, also the manufacturer was looking into that. and they made a modification. So when our model was ready, it was not anymore modeling what was going on. So how do you see this challenge of data-driven approaches into a continuous, reliable monitoring?
I guess I'll start with that one. For the first part of the question, when a new aircraft or a new system is installed, you don't have any operational data. I think understanding the behavior of the system is your first kind of foundational piece of knowledge that you must have. So obviously the system was designed, so you'd probably need to coordinate with the OEM to understand normal operation, to define normal operation, and translate that into probably a behavior model to understand and identify normal. That's the path that we've gone with kind of some of our early development, is first defining normal operation and going from there. I'm sorry, the second question.
When there is a modification.
So certainly that is a complexity, and something I think that just can either lead to false positives or potentially the results being inconclusive. And it not necessarily a modification, it could just be a slight difference in aircraft operation environment, as we were discussing earlier. It could also be that there's a slightly different location for a sensor due to a configuration change in production. Maybe the sensor's in a different place. That certainly can lead to different results as well. And those kinds of very fine details can lead either to model complexity or just false positives, I guess. Things to keep in mind for sure. So,
to the first point of Bruno's, I would like to ask you, do you see the role of AI there that can play a role to educate the system, so to create some synthetic data, for instance? Would that be possible?
Yes, I think absolutely there's a role there. I think there just needs to be an understanding of the added complexity that will require, and you'll need some way to indicate to the model the differences. So identifying where those differences are would be the foundation. Knowing that a sensor is in a different location on a subset of aircraft. And there's certainly some complexity there. Possibly your model could tell you that. After you ran with results and you're seeing results that aren't necessarily making sense. There certainly would be a lot of time dedicated to that and required. So.
And I guess the lack of data, I guess if you start your prognostic health management system from the design on, then during the certification of the particular subsystem, you can at least collect part of the required data, maybe not all of it, but...
Can I add also something? Yes. Yeah. Let me also add this. We talk about data-driven approaches, both for SHM and PHM. One thing to keep in mind is that if we start building such algorithms, let's say, which rely on training data, as they mature and as time passes and as these things get more and more data from real life, it is apparent that the algorithms would be retrained periodically with a richer set of data, and they would come, and as more and more data get into the algorithm, they would become better and better and better as time passes, and as we go to the future, they will continuously become better at performing their tasks, either diagnosing damage or prognosing damage.
Mm-hmm. Mm-hmm. Yeah, that's fairly common in helicopter health and usage monitoring systems, that you set a threshold for your particular KPI, and in the course of the life, you lower or increase your threshold level for the alert. It's accepted means.
For me, though, so this is good because you're correct. But the question is the process for qualification, the system for you need credits. Now is one good moment for, in this case here, discussion to EASA for the application of this. Your ReMAP is good. I have many functions use the machine learning. Well, yes, I have one this. Who is idea for guarantee, for one process for guarantee this qualification? This moment is very important discussion. Okay, we need regulators about this. Okay, because this is very interesting for us. It's very interesting for us.
There is a question or a comment, please.
Yes, good afternoon. So my name is John van Doeselaar from Airbus Airframe Engineering. I have a question, it's more a pragmatic question. So let's assume we have the technology that works. Let's assume we have a business case that works, which is not always the case. Let's assume that we can convince the authorities that we can certify the system. Let's assume we're all there. Yeah? A lot of assumptions, true.
Only this?
Let's assume we are in such a situation, yes? The 2 days maintenance program, so the scheduled maintenance program, is huge, it's enormous.
Mm-hmm.
Let's assume that with all this technology, we can update the scheduled maintenance program in a regular sense. Now, I would like to ask the question to the panel. We heard about dynamic maintenance. How easy is it, for instance, for you, American Airlines, or maybe for your customer, the military side of it, how easy is it to apply such a dynamic maintenance formula or a dynamic maintenance policy in your day-to-day operation? We can do, probably if we have all these assumptions in place, we as Airbus, we can give you an updated maintenance program every month, maybe every week if we want. What is acceptable for you, American Airlines, or for your military customers, in terms of what you can accept, what you can accommodate?
Yeah, I guess I can get started with that. So certainly that is a great question. I think what would be acceptable would be determined by the technology and the capability that the airline has for scheduling. I think that's one of the core focuses for the ReMAP was the flexible scheduling model and the added benefit that can provide. As you know, right now, our maintenance program is vast, it's large, have a large fleet of airplanes, and right now, maintenance program is pretty fixed. Generally, I would say almost every item is a fixed interval. There's enough complexity there that we have struggles. When you introduce a maintenance program that's no longer fixed, whether it's half or all of the maintenance items, there certainly is going to be a complexity introduced there. So I would say right now, the airline would be dependent upon a solution that allows us to easily implement a flexible maintenance program. I would say right now, most or all airlines probably don't have that. So certainly that would be something that would be a requirement if all of the other assumptions were made true. So, yeah.
My customer is not prepared to do that. No, it's very difficult. They have a fairly strict maintenance program, and even with the equivalent flight hours that we calculate for them, they tend to stick to a conservative approach. And the only true benefit they have is that at least they know that the replacement of the center wing, which is the most fatigue-prone and critical component of C-130, at least they can plan the replacement of that center wing. So that's really how they use it. And for the rest, they stick to a conservative assumption regarding the equivalent flight hours. It's very difficult to convince them to go otherwise.
And one additional comment I would say related to the reactive maintenance is that's where our airline has seen benefit, is taking the reactive maintenance and turning that into scheduled maintenance, where you can accomplish that at a station that has parts, manpower, and time to do that maintenance. So certainly our airline is able to handle that, but I'll say that's a fairly small percentage right now of our total maintenance. So, yeah.
I should add what I said. The data that we generate is used for a very slow feedback loop, if you like. We collect data, and every 5 years, the OEM becomes involved and does their math and updates the fleet structural maintenance plan. So there is a benefit there, but it's a very long loop, if you like.
Great. Given time, I would like to go to the last point of our discussion today, which is about the new generation of engineers, of educating the mindset of having CBM. So today with us, actually, we are very happy because we have research, we have the one who manufactures, and we have the one who operates. So I would like to ask, what do you need? What do you need? And maybe me as an academic, I ask, what do you need me to deliver to you guys for the next coming years or decades, that you have a profile that is towards the CBM?
Sorry. It's a very good point. For us, very good. It's in manufacture. In design and education, I believe that this aspect of the maintenance and the operation have to be better explored by universities. These disciplines, including disciplines this. The new maintenance paradigms need to be taught and debated so that the next generation of engineers have enough knowledge to be able to develop more efficient and economical procedures. Is one question very important. Many engineers don't, when I go to manufacture, don't know this word. Is prepare for developing the aircraft, is understand the aeronautical, understand the structure, understand the materials, but don't understand the maintenance and the operations. This is very important to know this. And they included this Industry 4.0, okay? Technologies should also be taught and discussed within the scope of asset maintenance. In your case, aircraft, okay? Students should be encouraged to think about a new process and the new technologies, thinking to apply then to the development of the aeronautical industry. One other point I talked about yesterday, the Bruno, this is very interesting for the impacts, for the maintenance impacts for the new green zero emission technologies on the aircraft operations. It's very important the students understand this. It's this new future about this and the conditions about the ESG regulations. We, in manufacturing, we need for new students, engineers, have more understand about this approach. I'm sorry, but many times we have the engineers in Embraer, but don't have one understand this word. It's very for us because increase understand for these impacts for the ideas these students create new futures or opportunities for the increase in the efficiency about the maintenance, okay? This is very interesting for us.
Marcel, what's your...
Yeah, well,
what's your wish, so to speak? So the aerospace engineering faculty delivers a lot of employees, let's say, to NLR. What would be your wish, so to speak?
Well, a lot of the work we do is IT related. And we got two types of persons in my department. We got domain experts and IT experts. And what I find is that I've got good IT experts, let's put it like this, but I prefer domain experts with a affinity to IT. Domain experts, fraction mechanics guys, structural health management guys, who also can program in Python and know how databases work and stuff like that. So I would say this joint knowledge of the domain, the aircraft maintenance, aircraft sustainment, coupled with IT tools. So at least they have to speak Python. Yeah, definitely.
Anthony?
Yeah, similar to what was said previously, the CBM is still, I would say, in its infancy. There's still much to be learned, and I think I would say just about every aircraft out there right now wasn't really designed with this in mind. Most sensors installed at delivery probably weren't installed for this purpose. And I think an importance of keeping CBM in mind during aircraft design is critical. I think that's something that can change the future and enable CBM to be more productive and more powerful. And as far as something for a student, something for a new engineer to look into is the fact that data is very powerful, and having the tools to be able to harness that power is the future for CBM. So whether the tools are knowledge for machine learning, and taking the vast amounts of data that we have and providing actionable insights, that's really the future. So.
Someone from the audience, David, please.
Sorry to be dominating and so forth. Marcel, exactly what I was thinking. Subject matter experts with the sprinkling of IT. That is kind of what we need. Now the bad part is aviation's not sexy like it was. So the new engineers out of school, we have a hard time hiring them because they want to do the real fun, sexy stuff like Amazon and Facebook and Microsoft and those. We have challenges, and so I think it's incumbent upon us as the industry to basically have like an industry education, if you will, and let the students know that there are these opportunities out there if they can solve some of these things. And we are looking for people with these skill sets for that. And then the final thing for students, kind of thing, always ask why, kind of thing. And it's good that you're at the point now because you always ask why, but keep asking why. Don't accept the answer of, well, that's the way we've always done it. That's the way we've done it previously when we didn't have that data, have this new data. Now, decisions were made in the 70s and 80s based on the data we had at the time. That's what the aircraft design nowadays is based on, and so forth. So now if we have a different data or additional data, some of those decisions might now be different. So always ask, why is it that way? How did they arrive at that decision? What data was it based on? And so forth. And that's what we're going to need in the future.
Can I add one thing? I think your question about education is very interesting, because what we're trying to achieve with the ReMAP is basically going from a predictive way of doing things to a more reactive, when you observe the world and you get the data and you harness the power of data, rather than just modeling something and then relying on your model. And I think education can also evolve in the same direction, because a lot of the education, not only university, but even at lower levels, is all based on the fact that you study science and science predicts the world, and that's how things go. And there's very little teaching about observing the real behavior or the real data and using more of that information rather than relying purely on theory to predict reality. Because what we find in this area is that complexity is so high that the chance of being able to fully predict something with a theory is an illusion. I think we had that illusion for a long time, that improving the theory, you will in the end be able to predict everything. But the reality is that data is more powerful than theory to solve a lot of issues. So maybe also in the education, putting more emphasis on data-driven processes or data-driven decision-making rather than theory-based decision-making would be a useful change.
Thank you, Daniele, for your intervention. if I can add a bit more, is that the focus, when I heard you and Daniele now, that is to put everything on database approach. But still, it's always important to keep in mind that we have physical system and that even if with theory we cannot explain everything and understand everything, at least we can get the global trends and a lot of information based on theoretical model and on physical model. So having students that lose all their physical abilities to get intuition regarding problems and stuff like that, it's also a bit dangerous. So I think there is a balance between being able to manage data-driven approaches, but still having some physical insights regarding what's happening, because a brake is still a brake, whether there is a sensor on it or not. So.
I was not just do only data.
Sure.
The solution is somewhere between. Okay, given the time, because we are 3 o'clock and people need a break, including myself, I would like to ask to the panelists just the last words that you would like to share with us of the discussion that we have today. Maybe a quote like ReMAP rocks, maybe. it is up to you. Yeah, please, just say it.
Yes. What I haven't heard this today, well, it's been mentioned, but the whole energy transition, it makes it even more relevant as HM, PHM, etc., because lightweight structures will require SHM, I believe. So keep up the good work. And, thanks.
ReMAP is very good program. It's very good provocations for in the sites, in the community. It's, I think so. Congratulations to many people's work at this. My finish for about these discussions is ReMAP not finished. Yes, this is one new step. Concluded. Other steps you need continues. But the community, everyone good values about the results about this. Today morning, you look in this 5 years for working this many features about the SATM and the PHM. It's important. For me, in the finish is this CBM need the SATM, need the PHM. SATM and the PHM need for reliability level, for guarantee for application. CBM is needed this. If I think so, this is one new step for continuous discussions and it continuous partners for us. Okay?
Just a small spoiler, on Wednesday afternoon, the coordinator will announce something new that is coming. So ReMAP is not going to end.
Yes, I understand. Sorry.
She's going to announce something. So we're waiting for the coordinator, and we kept it for Wednesday afternoon, so we want everyone to stay, not to leave.
Oh, yes. Sorry. Sorry.
Yeah, I think ReMAP certainly is able to address a need. There's going to be a need to allow all the partners to coordinate, communicate, and really harness the power of the data. And I think ReMAP addresses that. I think also that there's still work to be done, and I think expansion and attention to continue and expand the collaboration is going to lead to success. So.
Thanks. So we are ready for a break.
Yes.
No coffee.
Yes, 3:20. We are back. 3:20. 3:20.
The boss says 20 past 3.
Sorry.
It's nice to meet you.